In this digital logic and design series, let's explore counter design, specifically focusing on Modulo-N counters. We will learn how to design counters with arbitrary count sequences. A Modulo-N counter is a sequential circuit that counts from 0 to n-1 and then resets back to 0. For example, a modulo 5 counter counts in the sequence 0, 1, 2, 3, 4, and then back to 0, repeating the sequence. To design a Modulo-N counter, we will follow these steps. First, we will create a state table. Then, we will perform state assignment. Next, we will construct an excitation table. Finally, we will minimize the logic to obtain the required circuit. The first step in our design process is to construct a state table. The state table defines the present states and their corresponding next states based on the desired counting sequence. For example, in a modulo 5 counter, the states are S0, S1, S2, S3, and S4 with transitions occurring in the sequence S0 to S1, S1 to S2, S2 to S3, S3 to S4, and S4 back to S0. The next step is state assignment. We need to determine the number of flip-flops required using the formula n equals ceiling of log base 2 of n, where n is the modulo value. Then we assign binary codes to each state using the determined number of flip-flops. The third step involves creating an excitation table. In this table, we determine the required flip-flop inputs for each state transition. Common types of flip-flops used in counter design include JK flip-flops, D flip-flops, and T flip-flops. The fourth and final step is logic minimization and implementation. We use Carnot maps, also known as K-maps, or Boolean algebra to minimize the flip-flop input equations. Finally, we connect combinational logic to the flip-flop inputs based on the minimized equations to complete the counter design. In summary, using a systematic approach ensures the correct counter design, and any arbitrary sequence can be implemented. Modulo-N counters have various applications, including digital clocks, frequency dividers, and control systems. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.